Welcome back to Phonetic Evolver. This is episode 6. I know it's been over a month since the last update, but things happen in life that you can't foresee, so anyway, here we are. So for the first week or so, I worked on fixing all the bugs that changing the file save system did, and once I was done doing all of that, I continued working on the actual program. Now, I don't actually remember everything I did because it's been such a long time, so I won't be able to show them to you now in this video, but I can show you what I do remember, which is the most important thing of the devlog anyway, and that is that I redid how the whole button node tree system works in the main window in Phonetic Evolver. Before I go on to explaining to you exactly all the changes that I made, you need to first understand what a Gui Toolkit is and how it works to fully understand exactly what it is that I did. A Gui Toolkit is a program that was already written to you by very smart people that allows you to easily create GUI programs. The way that it works is they give you abstract concepts like buttons and labels and tables that you can then use to create your own custom buttons on a GUI program that you're building. So for instance, these buttons up top over here, I didn't need to tell the computer between this pixel right here and this pixel right here, draw a rectangle, fill in all these pixels like here, black, and then down here, connect yourself to the text drawing library, start drawing a capital U, N, a D, a O. I didn't have to do any of that. I just told the computer, draw a button here, put in this image, write this text on it, and then when the user clicks on the button, do this thing. And this thing that it does is the only thing that I had to program, because the people that create the GUI toolkit don't actually know what you'll want to do with the buttons. Another thing about GUI toolkits is that, let's say when I wanted to put in the redo button, I didn't have to tell the computer, oh, go this many pixels from the top left, this many pixels down, place the button here. No, I just said create a box list layout thingy and make the first button be this, the second button be this, the third button be this, and it automatically does the layout for you so that you can keep adding buttons, and then if the buttons overflow, it's gonna add all on its own a little down arrow that lets you see the rest of the buttons. So let's say if I make the window small, you'll be able to see that it created the arrow for me. I didn't have to do animations like when the mouse hovers over the button it gets darker, or when you click on it it does a little animation. See, it starts off from the mouse and it goes out. Or here where the text gets darker when I hover over it, I didn't have to do any of that. The library did it for me, and I just tell it what type of button I want and then it's all for me. So now that we got that out of the way, I can explain what I did in the tree. Basically, what I did until now was, for every generation, I put a button there, and I made the text of the button be the name of the generation at year of the generation. So over here, I just placed the button here, put in G1 at 0, and then let it be, and then I made that when you double click on the button, it opens up the generation, and if you single click, it just selects it. But the problem was that this was very slow, because basically, I can't do a layout like this down here because all the buttons have to be exactly where I want them to be so that you can go click and drag to pan around. So I had to move all of the buttons at the exact pixel location, but that was really slow. So I decided to draw the buttons manually, meaning that now I do tell the computer, put them at this exact pixel, go this many pixels to the right, this many pixels to the left, draw a rectangle up to this location, and then connect to the drawing library of text, start drawing a G, a 1, an at, a 0, go up a couple pixels from the middle of the button and draw a little line going up and then down, and then at the bottom go down and then up, and then between the buttons draw a Bezier curve. I had to do all of that manually using a drawing library, so I didn't have to do everything on my own, but still it's a substantial piece of work to do. So because I had to do all the collision detection now that makes sure that when I click on the button here, it knows that I clicked on G1, not on, let's say, I1 or in the middle of nowhere, which the library would have done for me. So let's look at another example to further illustrate my point of why it took so long to do this. So at this G1.5 button, you see the description of the generation is lorem ipsum dolores itamer blah 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 blah. I made it long just to test if it can handle longer descriptions. So I had to tell the drawing library that I used to make this to only put in the G1.5 a couple pixels to the right of the left of the button and a couple pixels down so that there's padding. I had to do that on my own to make a little algorithm that calculates padding so that over here here that's also padded, and on the right, on the bottom, on top, all sides. And then I also had to put in padding between the title and the description over here, and I also had to put space between all the lines in the description so that the words don't touch each other. I also have to create a wrapping algorithm that decides that once it reaches a certain width, it goes to the next line, because when you write the description, you write it on one line, so I have to make it that it wraps when it displays it on the screen. So all of that took time, which regular buttons would have all done for me. The problem was that after I spent all this time and effort doing this, it was still pretty laggy. So I tried to, instead of drawing it like this with a library called Cairo, which lets you do things like set source color, set line width, select font face, font size, and it just lets you draw a rectangle, and you tell it where to start the rectangle and where to go to, and then it draws the rectangle for you. I decided instead of that, since it's slow, to use OpenGL. Now, why would OpenGL help is because right now Cairo is using the CPU to draw everything on screen, which means that everything is being handled one instruction at a time. It goes first this pixel, then this pixel, and this pixel, and this pixel, and this pixel, and it goes through all the pixels one at a time. And that's not a very good way of drawing. Rather, what if you can use the power of the GPU to draw every single pixel simultaneously so that it renders much faster, because instead of going sequentially 1, 1, 1, 1, you draw all the pixels at once. So one way of doing that is by using the GPU instead of the CPU, because the GPU is basically tons of tiny little CPUs. And one way of utilizing the GPU is through OpenGL. But the problem was that after a full day of trying many different things, I could only get a black screen. I couldn't draw anything, so I ended up scrapping that idea. But it would have definitely been instantaneous, no lag whatsoever. But it would have been a lot harder to implement it using the GPU, because the way that it works is when you draw with the GPU, you draw all the pixels at the same time. So when you're drawing a single pixel, it doesn't know the state of any other pixel. It only knows about itself, because if you think about it, the other pixels are still being drawn. So there's no way the computer can know what's going on with those pixels. You can't test that pixel for a color or a value or something like that, because it's still being calculated at the same time. So there's nothing that you can do. So you have to make sure that a single calculation runs for every single pixel while doing different things on different parts of the screen. Like over here there should be a button, and over here it should be white. So that takes a different type of thinking that I'm not used to, so it would be hard for me to implement. Whereas doing things by using the CPU, you do things sequentially. So for instance, over here I'm telling the computer to draw a rectangle, so it draws a rectangle, and then I go down here and then I say fill the rectangle, and then I go down here, I move the cursor, I draw some text. But so it does that line by line, affecting the pixels that it affects. So it's much easier to do it this way, because that's how I'm used to thinking, sequentially. So anyway, it was kind of a relief that I couldn't get OpenGL to run, because that means that I don't have to worry about having to write a shader which is buttons and lines and text, especially text. That is the most dreaded part of it. So then I thought, what if I use C to do the drawing? Because right now I'm using a programming language called Raku, which is pretty slow, and GTK, which is the Gui Toolkit that I'm using to build this, was written in C. So writing it natively in C would be much faster than using a bridge from Raku to C. And the GTK bridge in Raku is also pretty slow, and it's only half baked. Like, it's not done at this point. So a lot of things are hard to do because it's not done yet. So first, before committing to C, which would mean a full rewrite of the entire program, I decided to just use a couple of functions from C within Raku. So Raku lets you talk to functions in C through Raku. So I decided to talk to C when I do the drawing to see if that would be faster. And yeah, it was much faster. So here you could see that all of these functions, all the functions that start with Cairo, are directly talking to C. And yeah, it was much faster, but it was still pretty slow. So I did some optimizations, like making it so that when a node is out of the screen, it stops drawing it. Right now, as you can see, like once it gets out of the screen, the Bezier curve between the generations also disappears, but I'll fix that. But for right now, I just left it in so that I could see if it actually disappeared or not, because once it's off the screen, I can't see it anymore, so I don't know if it's off the screen. But you can see that easily by seeing when it disappears off the right of the screen. You see what is considered the point of a button is the top center. So once the top center goes off screen, it disappears. Doing this was actually the biggest thing to making it fast, because once I zoom in, button to, let's say, a point. Let's say if there's just one button, you see it flies. I move my mouse, it moves with it, it works amazing. But once I move in more buttons into the window, you see it starts to lag. Also, I noticed that if you let the program run, the longer you let it run, the slower it gets, which means it's probably a memory leak somewhere, which needs to be dealt with. But because I'm working in Raku, which has a garbage collector, there's nothing I can do about a memory leak. I would have to write the code directly in C to deal with memory leaks. So, but getting all of that out of the way, another thing that I added that wasn't here last time is a timeline. So you could see, so if you look at the left of the screen of the tree window, you'll see that if I zoom out, it shows you the numbers on the timeline. And if I pan and by clicking and dragging the mouse while the mouse is clicked down, you'll see the years move together with the map. So that, let's say, year 125 is actually at the horizontal position of year 125. And if I zoom in, you'll see that after a certain point, new numbers pop in to where they used to be blank. So it's a dynamic ruler where as you zoom in or out, it changes where the points are. So as I keep zooming out, it gets closer and closer until a certain point when it's too close, where it adds new lines. Whatever, you get the point. So you can see I zoom in. Boop, doop. See, what's that? Alright. That's a bug. But you see right now I'm zoomed out to 3000. Even when there's nothing on screen, it's still slow. I'm zooming in, out, I'm panning, and nothing's happening even though there's nothing on screen. So to remedy a lot of this, I did some more optimizations. Like instead of going down to each point in the screen and then deciding if it needs to have a tick and the year number, I just went down to the first one, and then once the computer decided to put a tick, I can just jump to the next one, to the next one, to the next one without having to go between all the pixels between them to see if it should get a tick. So that saves a lot of lag, but it's still very laggy. So I decided to just jump into C and start rewriting the program. So the first thing I did, just to see if C is actually worth pursuing, because C is a very hard language, so I'm not going to break my head over it if it's not gonna cause anything to be better. So the first thing I did was redraw the timeline in C. So here I have the same project but loaded up using actual C, so that I can access the Cairo library directly and I don't have to go through the Raku implementation of the implementation thingy. And here you can see there are no numbers here because I don't know why, but you can see the numbers to the left over here, and you can see that I can zoom in, I can zoom out, zooming, and before it already started lagging when I was up to 3000, but over here, where am I at? I'm at 10 million, and now is when it starts to lag. So yeah, I can zoom in. So because I now see that C is actually going to be way faster, I spent the last couple days learning C thoroughly because I never had to program in C before, so I don't know the language. So I spent the last couple of days watching already 20 hours worth of tutorials, and I read through a book, and I have another couple books that I'm going to read before I start. But once I get C down in my head, how to think doing things the C way, I will restart the whole program from scratch, meaning not just the GUI but also the backend, because as it is now, doing the sound changes takes forever. Like if you want to do PIE, it's probably going to take at least a month to finish processing. So that is not good, because let's say you do it, you wait a month, it finally finishes processing, and then you notice that one of the sound changes you didn't put in correctly, so you have to reprocess it. That means that you'll have to wait another month until you get to see the results. So I'll redo that in C2 so that it should do it instantly. But before I do that, I'll need to learn how to create a custom programming language, a custom compiler, a custom regex engine to do all the parsing and lexing and everything required to process strings of text into meaningful instructions to the computer. So since I'm restarting from scratch, now you'll be able to actually follow my journey from the beginning and not from when I started making the GUI. So that should be pretty interesting. See you guys whenever the next devlog will be, to see me trying to work on C and causing a bunch of segmentation faults.